welcome to another episode of 3-Minute Videos from the channel. Today we now do question 1E of MAT 2007. So we have this really large polynomial and we need to find a range of values for which this polynomial has a negative value. What did I say here? Yes, this polynomial must have a negative value or else you didn't solve the question. For one thing, we can realize that x is negative. This polynomial is surely negative when x is greater than 5. Because if you look at this value greater than 5, so you pick this value, let's say 101, let's pick x with 101, so you have negative 100 here, negative 99, negative 98, negative 97, and negative 96. So therefore, x must be greater than 5. And we can also see that when n is even, the polynomial cannot be negative. Because let us draw a few graphs here. Let's pick y equals to x for a start. It will look like a straight line. And how about y equals to x squared? Looks like this. So how about y equals to x to the power of 2n plus 1, where it's an odd integer? It will look something like this. And when y equals to x to the power of 2n, it will look like this. In mathematical terms, we say that the domain of the function of y equals to x to the power of 2n varies across all the real numbers, but its range is greater than or equal to 0, or in other words, not less than 0. So we can draw a number line of the both ranges. We can see that it goes through the whole real number line. This is a one-to-one function. However, this is a many-to-one function. So you will have 0 here, it passes through 0, and it goes off to infinity. Therefore, we can also say that when n is odd, we will have the possibility of negative values. So n is odd. So there, we have solved the question. But just to tell you, another way of writing n is odd for this is n is congruent to 1 modulo 2. This might seem confusing, but this means that if you divide n by 2, you get a remainder of 1, which is really the definition of odd. Now back to the functions. You realize I called this 1, 1 and many 1, and there's also this possibility of one-to-many functions, like take y equals to the square root of x. Or more proper, y is plus minus the square root of x, because I find that's the more proper square root function. But if you want the one-to-one square root function, it will go like this. That means you have to restrict the domain of x squared to the positive numbers, and then flipping it along the line y equals to x. That's called an inverse function. And how about we do the proper square root now? Y equals to plus minus the square root of x. Or, as I might prefer it, y squared equals to x. It looks like a shifted version of y equals x squared, right? That's because we just flip the x and y values around. So basically, we're just flipping along y equals to x. So there you have it, a little digression about functions and a discussion into why this is negative. Of course, we had 3 signs and the dynamics would be really different. Like take Gaussian integers, for example, we will have negative 1 plus I, or something plus something I. And another on these strange parity systems, I've seen Eisenstein integers, where it's written as a plus b omega, where omega equals to the cube root of 1. This might seem a bit redundant, isn't it? Well, let me tell you, it isn't. Cube root of 1 is actually negative 1 plus the square root of 3i over 2. Actually, there are 3 cube roots of 1. There is 1, the one that you all know, there's omega, and there's also omega squared equals to negative 1 minus the square root of 3i over 2. So there you have it. Other number systems might be an interesting thing to go through, and it might be worthwhile to explore some of these number systems. Maybe you find home in there. Goodbye.